Covering a person with a blanket often symbolizes a significant transition in the life of that person. For example, when young men return from initiation, they are often covered in a blanket to symbolize the transition from boyhood to manhood. In other cultures, young maidens would present a blanket to young men as a symbol of respect and affection. In a similar way, once we have listened to the inaugural address today, we will cover our inductee not with a blanket, but with a gown and a cap.
Dignitaries and everyone here, I will just do my job, and my job is simply to introduce to us our inductee this evening, Professor Annlize Marnewick. She is the head of school for the Postgraduate School of Engineering Management, where she has advanced from senior lecturer to associate professor and now to professor in the engineering management over the last 9 years. She is a registered professional engineer. She holds a Bachelor of Engineering degree in electrical and electronic engineering and a BSc honors in applied mathematics. She achieved her master's in engineering, cum laude, right here at the University of Johannesburg, where she also attained her doctorate in engineering in 2013. While her education and qualifications are built on a strong interdisciplinary engineering foundation, its Annlize technical industry experience of more than 15 years that allows her to lead the School of the Postgraduate Education of Future Engineers with depth and insight. She worked as a requirements engineer and business analyst in the architecture, design, and implementation of several high-profile system and software engineering projects. During her tenure with the First Rand Bank, she was part of a project team that worked on a wholesale credit risk management system environment. The project addressed the business problem created by different business units, each applying their own methodologies for credit decision-making during the credit risk management process. The solution of a single view of a counterparty credit risk across the organization was central to achievement of one of the First Rand Bank's key objectives, the acquisition of profitable business opportunities with related credit risk management. The project's strategic and operational impact was significant. Credit business decision was made available at the start of every business day, along with a complete view of multi-party risk across multiple levels in the organizations. Financially, the solution brought a 2.3 billion capital saving rent across the group by implementing a Basel II on nominal terms. This translates to an annual cost of capital saving of about 230 million in perpetuity. Undoubtedly, Annlize's passion for projects and project management stems from these years in the industry technology project environment. She has been quoted as saying that she does not work on projects that fail. And you can ask the executive dean about it, and this is true. Indeed, her research output and journal publications speak of commitment to project success, whether it's challenging improved communication in project teams, eliminating the need for enhanced project management and leadership skills, or bringing the critical role of digital literacy in projects to the fore. It was during these working years in industry that she identified a need that would set the direction for her return to academia as a lecturer and supervisor of postgraduate engineering management students. Annlize observed that newly graduated engineers entering the workforce and project teams seemed to lack the problem-solving skills to identify and solve the hidden impacts of real business problems. The need to develop engineering management problem-solving skills has been at the forefront of her contribution to the discipline of engineering management, both at UJ and beyond. Some of her most prominent journal articles publications aim to advance the field of engineering education, such as her latest journal article in Teaching in Higher Education entitled A Supervision Approach to Facilitate Learning During the Master's Research Journey, and a 2022 study published in Systems Engineering about integration of international competencies into systems engineering graduate programs. At home, she plays her most fulfilling role as a mother to a grade 11 daughter and who dreams of becoming a wildlife researcher. Home is also very much a place where great minds meet, as is evident in some strong publications record across multidisciplinary project management research from husband and wife duo of Marnewick and Marnewick. Only 9 years into an academic research career, Annlize has authored and co-authored no fewer than 50 conference papers and 35 journal articles, published in prestigious journals like the IEEE Engineering Management and high impact factor journals like the International Journal of Project Management. Today, this established academic, experienced engineer, and project implementer states that she finds her meaning and purpose in the individual and professional development of students. 6 doctorates and 146 master students have graduated under Annlize's guidance as postgraduate supervisor. She continues to take pride in the important work of delivering engineering graduates who are ready and able to be the real-world business solvers, problem solvers of tomorrow. Thank you.
Thank you for the introduction and welcoming Dr. Ralape, Party VC functionary, and Dr. Marshall. I think in preparation of tonight, I reflected on my journey and are very aware that I'm privileged to stand here due to the grace of God and very little to do with what I've done. This alongside with many opportunities provided by companies and individuals I met along the way. So before I start with my academic reflection, I'm going to have to ask you to spend a few moments patiently with me, just acknowledging some of the support that was part of my journey. Like I said, most importantly, the grace I receive daily is what makes things happen. I was very fortunate to study with a bursary from ISCO. I think my generation, many of us, the engineers, was funded by ISCO at the time, and that's where my foundation of my engineering education started. There's various companies that has been very good for me. They have invested in me. They have provided me with a landscape where I can make mistakes and I can build experience in the project environment. And I just would like to quote Digital, Compact, RMB, and then UJ as well. My industry colleagues that were mentors that I learned with and that from whom I've learned a lot and has become lifelong friends. I'm grateful. Then at UJ, my supervisors, Professor Jan Arem and Prof. Leon Pretorius, that has been my supervisors during my own postgraduate studies. Then Prof. Marshall, the Executive Dean of the Faculty of Engineering and the Built Environment, and then many UJ colleagues, as well as that's been my support my mentors during my time at UJ. Then my students. I'm very happy that you're here and you make me love my job. So I'm very grateful for you. Then Professor Paul Mativenga, the responder tonight. I've learned a lot from you in our collaborations and our supervision of the PhD students. I'm grateful that you came out from the UK and for you and your family's friendship. I have learned a tremendous amount from you. Then my mother and my late father, they have taught me through education we can change the world. And then Carl and Leonie, thank you. There's too many things to mention, but you know what you mean to me. Then in preparation for tonight, my academic reflection, what I've done is, as a requirements practitioner, I've reflected on what must be done in our current approach when we do requirements engineering, if we really want to deliver sustainable solutions. So engineering activities has led to many technology advancements over the years. If we just think about the products that surround us, we all wear smart devices, it monitors our health. We've got electronic devices that connects us to the world. We have got 3D printers, our own 3D printed house that we've got on our DFC campus. We develop new materials that we use for medical implants. So there's a lot of new products that we develop through engineering activities. There's a lot of services. I think if we think about the digital services that's connecting us through banking, education, 24/7, we can do a lot more than a few years ago. Then through the softer side, we develop a lot of models, how we make decisions on water allocation, how we manage energy. All of this engineering activities reduce cost for operations, it creates efficiencies, it creates a lot of optimizations, and that's transforming our societal, our economical, our environments. Now, all of this is happening fundamentally through design, and the input to design is requirements. So if we put garbage in, garbage is going to come out. So requirements typically happen through collaboration with our stakeholders. Ideas are generated, problems are defined. Once we think we understand as engineers what the stakeholders need, we start with analysis, modeling, and we come up with a concept of a solution. Once we've agreed on the concept of the solution, we start with the design, where the concepts are evaluated, detailed requirements are identified, and where we manufacture, construction, and deliver the software and build and implement. So there's a vast amount of disciplines in engineering. The fundamentals is the same, but there's many different guidelines within each development, whether it's software, whether it's systems, whether it's products. Now, engineers makes up quite a small portion of our society. But if we look at the huge the impact they have through the solutions they deliver, it is significant. So if we think about it, the success of the industrialization has impact on the sustainability usage of resources. So it is important for us as engineers to just spare a moment and reflect a bit differently, with a different perspective on our activities we have. According to a recent report from the World Business Council for Sustainability Development, the built environment makes up 40% of the total global CO2 emissions. Now, the target is to halve that by 2030, which is 7.5 years from today, and full cycle by 2050. Now, the built environment crosses many disciplines, like I've said, but there's a lot of challenges and opportunities for us here. So the bottom line, and I would like to quote an author that my colleague has quoted also recently, Brent Freiberg and Dan Gardner, in their latest book. And they are saying, in the book called How Big Things Get Done, and they are saying, we are talking about projects at a large scale in a number never seen before in human history, without which mitigation and adaptation to climate change would be impossible. So this leaves us with a question: what should be done to get to this target as engineers while we're so busy doing what we're good at? So I went to literature, And literature is telling us that sustainability engineering, sustainability is not integrated in our engineering design. It's not integrated, it's not prioritized, it's not necessarily implemented. And this is not just in South Africa, this is international literature. So if we just take a mirror for a second in our personal lives, there's many ways that we can integrate sustainability. People is advocating for personal behaviors, in efficiency use of energy, diet with less meat, traveling options that reduce ecological footprints, reuse and recycle. In our professional lives as engineers, there is actually just one option, and the question is sustainability a critical concern when you approach the development of a system, the development of software, or a development of a product? How serious are we? So the purpose of this reflection tonight, as a requirements engineer and practitioner, I focused on asking some questions and reflect what changes is needed as a requirements engineer when we do some work. I've started this reflection to understand how the requirements landscape will change, and I've raised some open questions. I haven't necessarily answered them. We don't necessarily have all the answers, but that's how change can start. So starting with the question how the requirements landscape is changing to engineer more sustainable solutions, we start with stakeholders. Requirements typically are elected from our stakeholders to identify what they want the system to do. In general, the focus is on the stakeholders that would be directly impacted. To understand the sustainability impact, consideration must be given to the direct, indirect, and rebound effect of the solution. To gain insight from this indirect and long-term effects, we have to expand the stakeholders. We can no longer just engage with stakeholders within the system, within the organization, within the project environment. We have to include stakeholders that's representing sustainability relevant positions, as well as those that are potentially affected, and we'll get back to that a bit later. The Karlskrona Manifesto principle noted that sustainability transcends multiple working disciplines. Working with people across disciplines will address the challenge from multiple perspectives. So if we expand the stakeholder, it immediately impacts the context boundaries, because the context is no longer fixed in a scope. It notes because small impacts can create a rebound effect. So the boundary changes to a multiple dimension expansion. Requirements, we can no longer not include the sustainability requirements when we think about what is the goal of the system. Requirements is a given. Sustainability should be a concern as independently as from the purpose of the system. This includes what the solution must do, forecast the long-term impacts, and iteratively identify the effects that is developed over the usage of the system. That brings us with a requirements engineer that's responsible to discover all of these requirements. A responsible engineer must take ownership of the system specified and the impacts thereof. The technical capability of the requirements engineer is not enough to make a sustainable first-class concern. The education, the awareness, the sustainability and integration of technical capabilities are required at an individual level. The change comes from multiple challenges that should be considered for us to move forward. We don't have all the answers, but we have to start deciding how we're going to move forward. So what I'm going to do tonight, I'm just going to start with one challenge, and that's the challenge of including multiple stakeholders. So if we think about our stakeholder base, addressing sustainability in a robust manner requires us to take a diverse and conflict perspective seriously. We cannot try and get everybody to agree into a single view. It's not possible when you work with diverse stakeholders. That's challenging us because we always want to get to a single solution so that we can build it. This is not going to be possible. During the problem identification, stakeholders are to be included that are impacted directly, indirectly in the future, practically, we do not know who's going to be impacted in the future. There are suggestions to include sustainability experts. We all know there is not many of them around. So what we can do, we can deliberately include very diverse stakeholders that help us not to overgeneralize. There are suggestions to consider underrepresentation of minority groups based on the context. The context of the problem would be quite specific to make your decision on the minority groups, but it can go over gender. It can be generation-based, based on age, socio-economical status. It can be discipline-related. The principle, however, to still keep quality designs would be to balance your stakeholders across skill that has got analysis and behavioral dimension and knowledge, academic, indigenous, experimental, and practical. Now, the one thing that we agree, what we said is we have to take conflicting perspectives seriously. We have to understand the outcome of that. There is no single solution possible because we cannot agree a single solution. The only thing that we can do is we can agree that there's multiple ways to get there. And we really need to understand in depth what the implication of each multiple way is before we make a decision which pathway we are going to select and why we're selecting it. What's best for whom, and that's the reason we're selecting it. So if we understand, we have to have a very good understanding of these alternatives. The first challenge we will have, is the communication activities. If we expand our stakeholder base, we already know from history that the communication was the challenge and requirements. Due to more diverse stakeholders, expanding the boundaries, this communication activities is going to increase and our challenge is probably going to become more. So the question that we have to ask ourselves is the teaching and body of knowledge focusing on the communication and engagement during problem-solving world class, or are we focusing on the technical capabilities? Because if we want to co-create during the requirements activities of the engineering of projects, new solutions with more diverse stakeholders involved, the facilitation of the co-creation effort becomes much more complicated. The second challenge that comes with the pathway approach, we're going to have to understand. We have to integrate the sustainability requirements. To transition to sustainability, the sustainability requirements needs to be integrated up front. We cannot, once the solution is built, only decide on we now need to do the sustainability integration. Research has been done across disciplines. Various disciplines within the engineering field has provided some guidelines of what kind of requirements must we include. Product, if we develop product, we must look at the materials we're using. Is it sustainable materials? Are we reusing? If it is systems, software systems, we need to look at the participation and access to the software. Is it inclusive? What exactly is the energy usage? So there is a lot of sustainability requirements that we need to include up front, and we need to think carefully how we're going to measure it before, and that needs to align in addition to the purpose of the system as very important. The drive for organizations to become more mature and include sustainability requirements as mandatory requirements will depend on driving forces from a legislative environment. I think we all know it's not going to happen overnight. So society, as well as the leveraging of individual skills and capacity and the mindset of engineers towards sustainability, is critical. we need to keep in mind somebody must drive the net zero effect. We are saying in 2050 we want to be at net zero. But if legislation only starts forcing us in 10 years to start implementing it, would our engineers be equipped with the right skills? So the other change that's going to happen in the requirements approach, so it was the expansion of the stakeholders, inclusion of the sustainability. There is multiple approaches, there's multiple pathways to get to a solution. Now, to decide which pathway takes us to the best sustainable solution, we need to understand the first order, the second order, and the third order impacts of each solution before we actually can start building. So the first order impact. We need to understand the direct impact of how each potential solution, demand for resources, would develop during its life cycle. We need to quantify, and this is a typical engineering activity, it's nothing new, such as life cycle assessment, footprint analysis, energy analysis. However, this typical engineering activity was never utilized in requirements activities. It's only being done after the solution is delivered. We're now saying we need to initially derive our alternatives, and then we need to quantify that. The second order impacts, we need to start quantifying the indirect impacts. It's the social economical interactions to quantify the potential adoption. Now, to explain this to our non-engineers here, I'm going to use a story from Prof. Jan Arem. So, companies recently like to install new energy efficiency aircons. So, there's a company, and they have decided they are going to save a lot of money, and they are going to install energy efficiency aircons. They spent the money, they've installed the energy efficiency aircons. What happened? Their energy usage went sky up, and they were very angry with their contractor that implemented the energy efficiency aircons. So our Professor Jan Arem is an expert in M&V. They got him out. The first thing Prof. Jan Arem did when he had to investigate why the energy usage went up and not down, he spoke to the users. He asked them, what are you doing with these new aircons? And they saying, no, the old aircons we never used because they made a noise. Okay? And now this new ones is brilliant. We switch them on all the time. So there's user and technology interaction happening. That when they have specified the potential solution, they have purely specified a technical solution. They have not looked at the indirect social technology interactions. And have they done that, they might have decided to never install aircons and just take the old ones out and put windows in. All right, so those are our things that we really need to start thinking about. How does the social and interaction happen between the technology? Now, the third order impacts that we need to think about is the rebound ones. That's where we have natural and human interactions and determining the environment's impacts due to social adoption. Now, it is very difficult. If we think about the cell phone, I recently read an article of the engineer that developed the cell phone back in 1996 or 1995. He has said he was never imagining a cell phone being used as his grandchildren uses it today, and he acknowledged he doesn't use it that way. So a cell phone was created to phone from anywhere. Today, a cell phone is actually not a phone anymore. It is a device, we bank on it, we talk on it, we message on it, old people communicate on it, it gives them a social connection. So the usage has created a rebound effect on the materials that's been used for cell phones. So for complex cross-discipline situations, these diverse activities are really, really very difficult to estimate. But if we're not going to start understanding that, we will not select the pathway that takes us towards sustainability. We might select the pathway, like the other customers, away from sustainability. The current challenge is this analysis is making the analysis part of requirements much more complicated. We've been doing the first one. The second one, we know as engineers, but we've never used it in requirements, so it's a lot more work. The third one is actually not an engineering activity. It's much more natural science, so we need to go and ask our science colleagues to help us here. So we could create new methods, or we can start working in a cross-discipline way. So once we've created all of these pathways, and we really, really understand how the social interaction happened with technology, how the interaction could happen with the natural environment, we could maybe start delivering more sustainable solutions. Now, the quantification through this in-depth analysis up front, before the detailed design happens, will lead to a lot more informed decision-making. A great deal of thinking will happen and be facilitated up front. This thinking is not just thinking, the analysis is going to happen. The justification for sustainability integration will be developed over time, in a similar manner to how security considerations developed from the 80s to today. Today, cybersecurity is an absolute must. It's the new warfare of the future. And sustainability will be maybe not a warfare, but we have to start thinking as educators, how do we prepare the skills of our future engineers until the company starts prioritizing it? So the open questions I've asked is, are we preparing them for the work in the cross-discipline teams, and are our engineering managers that generally becomes responsible for managing these implementations and these solutions equipped to co-create the solutions with the stakeholders? Because communication, we know traditionally, is really difficult. They're very technical focused, and we need to really think about that. Now, the pathway selection, if we look at what we've said here, what we can pull out from our learnings is there's a lot of early thinking that's going to happen. That's the first principle. In order to develop robust pathways, the upfront requirements and alternative solutions would require serious work before the design can start. And the question we have to ask ourselves, is the commitment there for sustainability, and are we serious enough to do the required upfront pathway definition, quantification, and selection that it requires us? The second thing we have to take away from this is there is no single solution. There are many solutions. Some could go towards sustainability, some would move away, and there is significant effort to produce the deeper results from the analysis to highlight which pathway will take us where. The third one is interactive. We are going to have to allow for ongoing learning and interaction between the stakeholders. No one has an understanding of what the solution is. We're going to have to learn and change, and learn and change. We're going to have to construct, learn, reconstruct. We do not know the answer, we need to construct it. So we need to be prepared for change. The selected pathway will be the input to the design process, where the design part can start based on the selected pathway. However, the pathway process is an intertwined process between requirements and design. We can no longer think in logical steps as we might have thought in the past, because we're all going to have to work intertwinedly together. Solutions, according to literature, that meet sustainability challenges are likely to be radically different from the conventional solutions. And the question we have to ask ourselves, how do we get serious about the work that sustainability requires from us? As you can see here, there is a lot of work that we need to do. As a requirements engineer, for me, it's clear that some changes required significant communication. And based on history, the communication challenges is really tough on projects. A lot of projects fails because people doesn't communicate with each other. People think they know what the stakeholders want. So we need to start thinking much slower and then only act fast. We cannot act without this deep thinking beforehand. Now, transformation towards sustainability. If we think about the target that we're sitting with, built environment responsible for 40% of the global emissions, we should be quite worried as engineers because it's a lot that we must reduce. How do we get this right with all of this new work? So there's three approaches that can be used to create the transformation. The first approach is structural. This is where we're going to be guided by changes to how production and consumption is done. That would happen from a governance and society. It can happen systematically, where we would start being driven from policy and having to achieve certain targets. And that's when companies will start enforcing and being serious about sustainability. Or there's an enabling approach. Now, this approach focuses on empowering individuals as agents to take action and create the change. As engineers, the transformation of engineering solutions is not going to happen overnight. That's realistic. It's only going to be maturing over time. But we have to start some change, look at the response, and learn from the response. As academics, we can utilize the enabling approach, and we can empower future engineers through education to lead the change in sustainability thinking and the application of sustainability practice. As engineering education, the question cannot be, is sustainability important enough to integrate in every project or design when we facilitate learning for our students? Instead, it should be, how can it be integrated? What can we report? What worked? And what have we learned? For me, the immediate response is to look at the education, to develop the responsibility in the mindset of the future engineers, teach them that they know that we intentionally have to solicit requirements from a wide range of stakeholders, which include users, non-users, that may face the consequences of the solution now and in the future. The definition of the problem to be solved should not be boxed in, like we like to do it so that we can design. It should really be defined much wider so that we can think about the future. We cannot not generate alternative scenarios. We should take the alternative seriously. We cannot prematurely evaluate and select our solution so that design can start without proper analysis. The main challenge is that engineers are humans, and we do not think and act rationally. Our decisions and actions are shaped by our experiences, by social norms, by the context, by sponsors' target dates, and among other things, and our own cognitive biasness that influence our views. So to prevent our individual cognitive biasness from impacting our designs negatively, we really need to integrate a cross-discipline approach. We need to understand the future implications of our solutions through collaboration and resources that can only come from conflicting views. A cross-discipline teamwork integration in education projects and programs is an opportunity that will enable and inspire new sustainable solutions. This way we can deliver graduates to society asking the right questions, integrating alternative views, and have sustainable thinking when they are solving business problems, and hopefully walk away from the wrong projects. So as engineers, we have the opportunity to develop more sustainable solutions. I've shared the changes that I believe we need to consider during requirements. It is my opinion that we need to do a lot more upfront in the requirements. Secondly, as educators, we have a responsibility to consider changes required in our education approach and content to equip future engineers that will take the development of sustainable solutions forward. Thank you for listening.
Thank you, Professor Marnewick, for an excellent lecture. I have a dream, and my dream is of a sustainable world. So imagine if, as engineers, we designed these buildings with the net zero agenda in mind. Imagine if all our cars could support the net zero agenda. Imagine the aircraft that we use could support the net zero agenda. Then we will have secured the future that we want. But how do we turn a dream into a reality? And that is the question. I think one way is to put it in the Bible, or maybe in the Quran. But I'm not going to start preaching. I think Professor Marnewick gets it. Requirements engineering is the Bible for design. So if you put something in requirements engineering, it will be done. So I think she has highlighted a key aspect. So if you have something specified in requirements engineering, it will be part of the design review, it will be part of the evaluation of the project. So that is the transformation we need. So we live in a world where we design things for linear consumption. So we design and assume a single life cycle. But we're increasingly creating impact on resources. So how do we transform this? If it had been specified in the design requirements that the product that you have designed needs to have 5 life cycles, then it will be done. But if it is not part of the key document, then we do not realize the dream. So I think today's lecture is important and transformative. Professor Marnewick also highlighted an important aspect, stakeholders. So we are all stakeholders in this room. So if you want a sustainable world, then you are stakeholders on how your house is designed, on how the car that you drive is designed, and which type of aircraft or whether you fly or not, we are stakeholders. So stakeholders are key in terms of the transformation we need. But life cycle assessment, which is a key tool we use for sustainability, teaches us that we need to look at the stakeholders in a different way. So we talk about a cradle to grave. So every product has got a birth and a death, so you've got a life cycle. So along that spectrum, there are different stakeholders. So as designers, we should not just look at the immediate customer, but we should look at the spectrum of stakeholders. So imagine if you're designing an electric car. You want to know how the charging systems are going to work. The electric car is predominantly the battery. You want to know the end of life. What happens at the end of life of my car? So when you extend the system boundaries, that actually creates the solution space. It creates more innovation. This is what companies are beginning to realize now, that the expansion of the solution space, the system boundaries, does not only give us a robust solution, but it supports innovation. So that's a very important aspect. So I'm going to digress a little bit. In 2017, in the UK, there was a major disaster in a high-rise building. This high-rise building caught fire, and more than 70 people died. And this has been the subject of major inquiries. And a colleague of ours at the university has been taking part in the inquiries. And a few, obviously, reasons are advanced. And the question of attribution is always difficult. So it's very difficult to pin what is the actual cause. But what is emerging is that the cladding on the high-rise building was probably substandard. So this is the material that is supposed to stop the spreading of fire. So over 70 people died, and a lot of families are living with that strategy. So what the person leading the inquiry asked one of the survivors, what should have been done differently? And the survivor said, if only the users were part of the team that was engaged in deciding what cladding could be put on the building, this accident would not have happened. So stakeholders are invested. Stakeholders will make sure that the solution satisfies their requirement. So the engagement of stakeholders is not just a nice to have. Sometimes it is critical. And that is the opportunity that we have to embrace. So Professor Marnewick also threw a challenge for our education systems. So we educate people in mechanical engineering, in civil engineering, and in the humanities. But these solution spaces we're looking for require that we rethink our education systems. We develop a new mindset, and we allow people to work in teams. And this is the challenge. How do we do it? We are used to the education systems that we have found to work, but the world moves on. The world and the requirements for sustainability, I think, force us to consider the uncomfortable, to look at alternative ways of delivering education systems, to look at how mindset is a key aspect of what we consider in education. So I think Professor Marnewick's lecture today was transformative. I think your lecture got it. I think the requirements planning, if I'm to go back, to realize this dream is the Bible, the essential document that we should put things related to sustainability. And that sustainability is not complete if we do not engage a diverse set of stakeholders. And that, considering cradle to grave, expands the solution spaces and enables a robust solution. So it has been my privilege and honor to speak after my great friend, Professor Marnewick. And I think it is my privilege for the executive to allow me to speak. And I thank you for all those present, in particular, Professor Marnewick's family and friends and supporters. And for those that are online, for me, sustainability is a dream, and we need methods of turning the dream into a reality. And requirements planning, as outlined here, the agenda that Professor Marnewick said today, is the transformation that we seek and the change that will deliver sustainability. Thank you.
Ladies and gentlemen, we have come to the end of our event today. I would just like to close by thanking once again my co-functionaries, Professor Daniel Mashao, Professor Mativenga, and once again, congratulations, Professor Marnewick. You confirmed something that I've always suspected, that engineers are human. And that is my takeaway for today. Thank you very much. Ladies and gentlemen, at the conclusion of the event, you are invited to partake in some refreshments in the hall and enjoy the rest of your evening with us. Thank you.
The University of Johannesburg, the future reimagined.